to record this session. Okay, and then we will see that how because once we get the idea of the Docker containers, then we will see that how the data inside a container can be stored on the Docker volumes, and then how we will see that how the Docker containers can communicate with each other with the networking. Okay, so the last part of this workshop will be an online quiz. It will be a fun game, nothing to worry. It's not a, of course, we are not going to give a grade or something, but it is a very interesting, fun game. So for this purpose, I will request you in the meanwhile, you should download this Kahoot.it app from Google Play Store or from the Apple Store for the iPhones. So and then please make sure that you are watching this workshop on the desktop or laptop. Do not watch it on your mobile phone. Okay, because once when we go to the online quiz session, then I will be showing you the question on your screen on your computer, and then you will be responding that answers on your mobile phone. In other words, on the mobile phone you will not see the question you will see through the blackboard. Okay, or I will be showing you the question and then you will be responding, and once the quiz is over, then we will have the result. Okay, and then result who got his highest score and like that. Okay, is there any question or suggestion at this time? If you have any question, my sound is clear. Please respond me. Anybody can respond to me that my voice was clear. You can write on the chat. Is it clear? Okay, yes, it's clear. Alhamdulillah. Okay, now let's go on. Okay, now let's look at the first thing, which is the monolithic architecture. What is the monolithic architecture? Actually, this architecture was the previous, when the computerization were started. People have started, or companies have started the computerization. They were the only option available for them was this monolithic architecture. So what is monolithic architecture? Simply implementing the business logic on one machine. Okay, like you have one powerful computer. This computer can be a mainframe, mini computer, or high performance microcomputer. So all business logic is accessible through a component called UI, or user interface. So the user accesses the user interface section, and the user interface action will route the user request to the business logic, and the business logic may need to have a database access. So in this case, the thing is that this is the all server, only one server in the organization. That server will have to be managed by the company. So okay, so in this case, if there is some issue with the machine, then the machine will have to go down, and it will take a long. The user will have to face a long downtime, so which is of course a unavoidable or unwanted situation. And another point is that this single machine may not accommodate a lot of users. Okay, so this is the few problems with related to the monolithic architecture. Now let's see some more problem. This monolithic architecture has slow release cycles, meaning that if suppose you have an application and you want to improve the application, so then you cannot do it anytime. For this purpose, of course, you have to develop the application offline, and then you have to bring your server down, and then you have to deploy. So in this case, this kind of practice may not be possible very frequently, because this will cause a downtime from the user perspective. So and then another thing is that suppose that you want to have a new release of the software. So in this case, there will be a team of developers. They will be working on some test server offline, and once they are ready, then they can contact to the operation team to deploy it onto the server. So in this case, of course there will be a kind of a downtime. And the last point is that in case of a hardware failure, uh, the whole application will have to be migrated manually to some healthy other server. So this will cause a problem. So these are the issues related to the monolith architecture. Okay, and we will see that how the what is the alternate being used these days, which is the microservice architecture. But before I go to microservice architecture, let me talk about another issue, which is called the software incompatibility issue. What does it mean? Actually, suppose you have a company and the company wants some product, so they hire some software house, or they give their project to some software house, and the software house, let's say they have two developers, developer A and developer B. Okay, developer A is working on a platform which is running Fedora operating system, Linux operating system, and it has a PHP 5.6 and Apache 2.4, for example. And then the developer B is working on another problem, and the developer B has a platform running over Windows 7, for example, and it has a different version of the Apache and the PHP. So what will happen? Then it means that the company, let's see what is the main issue. Problem is that the company has a production server which is running Ubuntu operating system. So then it means what? It means that the company, once they want to deploy the products developed by the developer, they will have to either buy a new hardware, and they need to install Fedora, and they will have to have another hardware which will have the Windows 7. Whereas they have different, it means that they need to spend some money in order to their product to work in the proper way, because the software developers will say their application, the software were working fine, because they were working on under certain operating system on certain hardware. So to make it possible, they would expect that the customer or client will have to have the same hardware and software to get the proper result of the software. So this is another issue. So for this purpose, there was a solution. That solution was called virtual solution. That virtual machine solution was introduced in 1998 by a company called VMware. What was the idea? That you can have one high performance hardware platform, and then you can make a virtual machine. Like suppose that you can make 3 virtual machines. What is a virtual machine? Basically, a virtual machine is a complete hardware simulated in software. Like you can have a virtual machine which is not a physical box. It is a software component which is working, which is hosted by the host hardware. The virtual machine carries the resources from the host platform. Like it takes some portion of the hard drive, it will take some portion of the RAM and other resources, and then you can say, okay, the developer BA has a Fedora, so you can install Fedora on VM1, for example. The software developer B had a Windows 7, so you can install Windows 7 on VM2. So you are fine. So this solves your problem. But at the cost of losing of some resources from the host platform. Your host platform is here. You have lost some of the resources from the host platform, because you have borrowed that resources to the virtual machine. And each virtual machine can install. You can install any separate operating system. They are all independent. Okay, please keep remembering some of the key points, because I will be asking in the quiz, on the online quiz, interesting quiz. So, so my point is that you don't need to have the virtual machine, all the running virtual machine at the same time. You don't have to run the same operating system on the virtual machine and so on. And then this idea sounds great, but there is a problem. Suppose that you want to have a one more software house to develop some application. You can use VM3. But if you go to for more software solution, you need to have more a special platform, like you need to have a Ubuntu operating system. Then can we have one VM4 on the same hardware? Can your host hardware support another virtual machine? So it will be everything will be choked at one point of time, meaning that you cannot have a unlimited number of virtual machines. So that problem also did not help much. Okay, so now we based upon these two issues, the issues related to the monolithic architecture and issues related to the software and compatibility, the concept of microservice architecture was presented. And before we go that, let me tell you about something about the cloud computing. Cloud native computing concept was brought up in the industry based upon the microservice architecture. And I will go into a formal example and definition of a microservice architecture in the coming slide. Okay, but before that, let me tell you about the cloud native computing. So this is the very much good trend these days. And what is basically cloud native computing? It is a microservice oriented approach for software development. Like you, very simply, you divide your one big problem into smaller chunks of the services. Okay, so in this case, it is basically you are dividing microservices, and then you are running the microservices in some kind of a virtual container. Container is basically, you can say, it is a small virtual machine, a virtual machine which does not require lots of resources. Okay, so you can see this picture. This picture shows you the cloud native computing basically glue or join force. What is the first thing in the blue color? It's called DevOps. This is the term I'm pretty sure you must have heard somewhere. A DevOps means that developer and operations, development and operations together, meaning that up until some time before, we have only developers and we had only operations team. So the developer and the operations team did not interact with each other. So the development team hand over their products to the operation team, and the operation team does not know what to do. They just deploy it. So they cannot deal the problems after the deployment will occur. So nowadays, the software companies need you to have the both capabilities. Like you should be able to do the development and operation. You should be able to know the ins and outs of the operating system and the operation, how to deploy your application. So if you have both skills together, so you get a good, very good amount of salary. So this is the DevOps. So the cloud native computing engage DevOps practice. And then there is another practice called CI/CD. This is the term you can search on it. This simply means continuous integration, continuous development. CI/CD, meaning that nowadays our business is relying heavily upon the internet and about the computing infrastructure, that we cannot afford the downtime even for a minute. It means that if you are down, you have a lot downtime, that you lose the business. So there's a practice called continuous integration. Like if you should be able to, while your product is in your item is in the production, you should be able to do the continuous integration and the development at the same time. And then finally, we have two things: microservices and the containers. So the microservices are running in the container. So the cloud native computing basically join all these things together. Okay, now let's go to the microservice architecture. Now we are going to see the in a formal way what we understand by the what we understand from the microservice architecture. Okay, during this time you are welcome to ask any question in the chat. Okay, what is the microservice architecture in very simple term? If you look at the first point here, it is breaking the monolithic application or monolithic problem into smaller independent application components. Okay, so in this case, each of this component can be defined as a lightweight mechanism to serve the business goal. Like each of the component can be independently developed. So the very good example you can see here can be developed independently, they can be deployed independently, they can be scaled independently. Okay, let me give you this example. Let me make it a little bigger. Then this will be good to see this diagram. It's a very simple example. For example, let's say you have a some online service. Okay, this online service, shopping service, for example, and this online, the front page or front user interface is accessible by the internet through any kind of the browser. Okay, then this online shopping service will allow a user to go to the account service, or it may allow the user to go to the product catalog, or it may allow him to go to the cart service, and then finally to the order service. So these all four services can be independently developed, and they can be independently deployed in some containers. Okay, like in other words, you can say they can be deployed in small virtual machines, or small independent. They can be encapsulated in independent working units. Okay, like for example, this account service can be housed in a simple machine, simple container, and I will see what we mean by container in the coming slides. But let me tell you one thing here, that they are not depending upon, there is a relationship or communication among these sub services, but they do not depend upon each other. For example, the account service may be developed by itself. Okay, there is no need to touch the other services. But if you remember, in the case of monolithic architecture, you have a one application will have to, whole application will have to bring down to update the user interface, for example. But here the user interface, the account service, because account service is dealing with the customers. Customer account, so you can update this one by updating, meaning that, or by scaling, meaning that you can improve the database size if you have a lot of users coming. So this you can independently develop. Similarly, product catalog, it can be scaled up very easily, because suppose the company is introducing more items, so they can be you can have a separate and large database size. So you don't need to touch the other databases, but only the product database. The card service may not need to have a very large size of database because of the you don't buy a lot of things at the same time. And then similarly, the order service will have a very limited, almost equal to the card service. Whatever items you are buying, you have to have that in the order service, because you are ordering them. Okay, so this is the example in which we can see that how the microservice architecture can help us to implement our application. Okay, if you have any question, you can ask me or need more clarification. Okay, now let's go to the containers. As I said to you that we have a microservices. Microservices are simply the small scale or component of a one monolithic application. So then in this case, that application can be executed in a virtual box or virtual machine, you could say, or simple virtual environment that is called container. So what is a container? Containers are lightweighted virtual technology that contains only the infrastructure element necessary to perform one microservice. So in other words, you can say that one microservice can be implemented in a one or can be encapsulated. This will be better word. They can be encapsulated in a virtual software environment or virtual component that is called container. Okay, and then each container can have its own library, and each container can have exclusive access to the processor, memory, and all the essential things required. Like it's not like a one big virtual machine. Because you have a virtual machine is just like you have a complete computer, and then you are not using the whole features of the virtual machine. But the containers only use a small thing as per required. So inside the container, you can have all the dependencies, libraries, everything needed for the container, for the microservice will be inside the container. And the very good similitude or similarity is with the containers loaded on a ship. You can see there is a picture of the ship here. This you can see on the ships. You can have seen on the Jeddah port that they have a ship coming, and all the items being carried by the ships are inside the containers. So that concept of containers actually is exactly used from the concept point of view in the whole containerization process. So one container may contain on the ship may contain some furniture, and one container may contain fruit, and some container contains some grocery items and whatever. So what does it mean? Each container have its own complete environment. So for the complete environment, the items inside the container do not need to go out. So they are inside everything is available inside the container. So that's the same idea we use. If a microservice need anything, then you have simply everything is available inside the container. So container are another thing interesting. A feature of the container are that the container are the portable software components or module. What does it mean? It means that if you have made a container of an application, then that container can be executed on any of the platform. No matter what is that platform, it can be executed on a Linux platform, or it can be executed on a Windows platform, or any other, or even on the Mac computer. So they are completely portable software component. Okay, and then there are the containers. Once we make a container, then you can put the containers, or actually I'm using the term container. Basically, I mean here the applications which is supposed to be executed inside a container. That application component or microservices you can retain at one cloud platform, at one place. Okay, and then you can ship it to that containers or components can be shipped to the anybody who's interested in. So there are most famous container hub is Docker, hub.docker.com. If you go to that site, you will see there are a lot of images, or the software component which are bound to run inside the containers are available. Okay, so there are other services as well available. For example, RKT by Core OS, and you have LXT from Canonical, and Azure Container Instance, that is from the Microsoft. And the famous one is the hub, Docker Hub. Okay, we will be using Docker Hub. So there is another interesting point. If you look at here, the containers are actually if you look at this point here, they are stateless. Like here, where I was here. Yeah, they are stateless. Look at this point. What we mean by status of a container? It means that if once you have a container running, it will retain the data as long as the container is up, or as long as it is running. You can bring the container down, you can stop the container, or you can remove the container. If you stop the container, no problem, the data will retain there because your container is not in the running mode, but it is a stop mode. But remove the container, then whatever the data used inside the container, that will be gone. So that's why we say that the containers are stateless. So it means that there should be some way we must use to store the data inside the container, and we will see that what are the methods available to store the data of the container. Okay, so the best way of keeping the data is in the somewhere else on the host machine. You can, and we will see that what is the method available to store the data inside a container. Now, Docker container is actually is a software platform. Now, what is that? Let's talk about the Docker. What is the Docker? I mean that we understood the container. So actually, the Docker container is the word together. But how to have a Docker? How you can make a Docker container, or simply how you make a container. So for this purpose, we need a software which is called Docker. The Docker is the name of the software. So Docker is a open source software for deploying the containerization process. So in order to make containers, you need Docker program. So Docker is a utility, in other words. So this Docker can be considered as a platform as a service product, and it will provide you the OS level virtualization, and it will help us to produce the software containers. And in our practice session, I will show you that how we can use the Docker. Okay. And what the Docker allows us to do, it allows us to build, test, and deploy the Docker application very quickly. And in other words, we will see that we will go through a whole complete Docker container cycle. Like you can have application, that application can be executed in a container, and we'll see that how to create an image, or in other words, an image is executed inside a container. Okay, a software image. You have an application, the application is converted into an image. Okay, that image is executed inside the container. So the Docker software allow us to make the image, to run the image inside the container, and it will allow us to also to transfer the images to a Docker hub, and then also it will allow us to bring some already made images from the Docker hub. Okay, the Docker, final point in this slide, Docker is available on Linux and Windows. So we will use the Linux platform for the Docker practice. So what is the conclusion of this slide? That in order to do the containerization practice, you must have a Docker utility program that you should install on your machine. Okay, now let's talk about what we mean by image or Docker image. A Docker image, or simply image, is a read-only template that defines the container, meaning that what is inside the container. Inside the container, we have an image. What is an image? It is the code that will implement the Docker image. Actually contains the image that will run your all application, your application program. Suppose you have a simple Python program. Okay, that Python program can be converted into an image. Okay, so that is the meaning of image. And what is a Docker container? It is basically the instantiation of a Docker image. Like it is the implementation of the Docker image. So the image cannot execute it itself. It must need a container. So we say you can start a container, and you must specify that in the container what you want to run. Okay, we will go in a hands-on session that will make everything clear, inshallah. So we use this hub.com to maintain the images. Meaning what? Let's suppose that you have a you assign your job, your problem to a software house. The software house did what? They divide your application in a very systematic by using the software engineering technique. They divide your one problem into several microservices. Okay, and each microservice is converted into an image. Okay, and that image, all images are ready. So what they will do now, these images need to be transported to the client or to the customer so that they can deploy that images in the container. So for this purpose, the software house will not send the developed image by email or by email attachment or by on CDs. No, what they will do, they will use a Docker repository or Docker cloud repository. So they will go to this site hub.docker.com, and they will, on the software developer will use a push command. It will use a push command to push the image onto the Docker Hub, and the client will use a pull command to bring the image. So of course, the customer and the developer and customer, they know that what is the name of their image. So they will, at the client side, he will use the pull command and he will specify the name of the image, and the Docker program will automatically take you to the Docker Hub. Okay, and then you don't need to say, okay, go to Docker Hub and get it this one. You just simply use in the Docker, you will give this parameter to the Docker utility. Okay, you say Docker pull and then you give the image name. So the Docker program will automatically connect to the Docker Hub, bring the image to your host machine. Once the image is there, then you can use again the Docker utility to run that image into the Docker Hub, a Docker container. Okay, it will be inshallah clear when we go to the hands-on session. So before that, let me see what is the procedure. Let me hear some information for you to have how you can have a Linux environment. Okay, this is very general. This slide is just general. Is just to say that what platforms you can use for the Docker practice. Okay, as I said to you, this whole workshop is mainly upon the is depending upon the Linux environment. So it is good to tell you that how you can have your own Linux environment. So you see that you can. There are two options for you. The first option is that you can make a standalone Linux platform. Okay. What I mean by standalone in Linux platform means that suppose you have a spare laptop or desktop, you can make that environment a complete Linux machine. There is nothing on it. Okay, so all of the resources are under the Linux operating system, and this is very good to have because we will see that there is something very important concept which is called Kubernetes. I will tell you about that at the end of this presentation. The Kubernetes requires you that you should have a powerful standalone machine. Okay, and why? Because the whole resources of the computer should be under control of one machine. So you should have a standalone Linux machine. And another important thing is that if you decide to convert your your laptop or desktop into a Linux machine, you should enable the virtualization feature on that machine. For this purpose, you need to run the setup program of your machine and then go to the virtualization option and choose it enable. So this virtualization concept is features available in most of the these machines nowadays, like all core i3 machines starting from core i3, core i3, core i5, core i7, they all support the virtualization. All Intel machines supported that feature. So that is the necessity for you to have. Okay, so what are the steps if you decide to make a standalone machine? So what are the steps for making the standalone Linux platform? So first of all, you need to have a bootable USB. or you need to have a bootable DVD or CD. Okay, how you make it a bootable? So in order to make a bootable USB, meaning what? Like on your USB, you will have the image of your Linux operating system, and you can download the Linux operating system image. Like all the images are available. The CentOS is same as Red Hat. Red Hat is the professional operating system that costs money, but CentOS is exactly same as the Red Hat. But the CentOS image is available on internet. You can search CentOS image download. You can get it. Secondly, you can have Ubuntu, or you can have Solaris, or you can have other Linux flavors. But the good one is Ubuntu. Okay, so you can go to this site, www.ubuntu.com/download desktop. At this site, when you go, you should be able to download the Ubuntu ISO. Okay, this Ubuntu ISO is called the image of the Ubuntu. So once you should have on your machine. Now okay, let me repeat. What I am talking about, I'm talking about how you can make a standalone Linux machine. Okay, what is the step? The first step is that you should make a USB flash memory as a bootable. So bootable means that it should allow the boot, it should allow you to load the operating system from the USB. So definitely your USB should contain the ISO. So how we can make your USB bootable, and how you can put the image of your Ubuntu machine on the USB. So for this purpose, you need to use a Windows platform. Okay, we are using Windows platform for what purpose? To make to put the ISO image on the flash memory, and to make it bootable. So for this purpose, you need a separate software which works on the Linux, on the Windows machine, that is called Rufus, RUFS. Okay, this sounds like somebody's name, Rufus. But this utility you can download from this website. Okay, so what this Rufus will do, it will ask you where is the ISO, and it will automatically make USB bootable and transfer the ISO to the USB. Once it is ready, then you just simply go to your machine on which you want to install the Ubuntu. You put the USB in, and then run the setup program to let it boot from the USB. Okay, so once you have done it, then it will install make the Ubuntu. So this is one option. Okay, the second option, if you do not have any spare laptop, or you want to do the practice of the Linux, the second option will be that you install the Linux on you make the Linux virtual machine. Okay, so you can install a Linux on virtual machine on the Windows platform. For this purpose, you can use, there are two options for you: Oracle VirtualBox and VM Workstation Player. These both softwares are open source, freely downloadable. So you can download Oracle VirtualBox or VM Workstation Player. I will recommend VM Workstation Player. This you can go to Google and then put say VM Workstation Player. You will see the link to download. And because we are all learner, so we are not using this for a commercial purpose. So it will allow you to download the version 15 of VM Workstation Player. So it is very beautiful solution, which I have experience of both Oracle VirtualBox and the VM Workstation Player. So I found VM Workstation Player more convenient. So you have both choices. So once you have an Oracle virtual machine, then you can make what you can do, you can create a new machine. And on the VM Workstation Player, it will, from the very beginning, it will ask you what image you want to put it on. So you have downloaded the Ubuntu image, and it is available in your downloader on your Windows 10 machine. So you just specify the path. Where is your ISO? So then this VM workstation player will install that, and then it will make the virtual machine ready for you. So that virtual Linux, you have a Ubuntu machine, but and also one thing important, before you do make the virtual machine on your Windows laptop, you still have to enable the virtualization on your Ubuntu or on your Windows platform. So this is what is the conclusion of this slide. I have just told you that how you can have a Linux platform. But as in this workshop, of course, we do not have the Linux platform, but I will show you we can use a special website. That website will allow us to do the Docker practice. Okay. Now let's go to the Docker practice. Docker practice. Now we are going towards our hands-on session. So before we go to the hands-on session, let me tell you something about. Suppose you have a Linux environment ready. Okay, then you should have the Docker utility available. This is the command you will use to install the Docker on your Windows Linux machine. Sudo apt-get install docker.io. This command will install the Docker utility. Once you have the Docker utility ready, then it will allow us to what? It will allow us to create the Docker images. It will allow us to the Docker container. Okay, you can, once you can create an image, it will we will create the image. Everything will do through the Docker utility. What are the things it will allow us to do? Make an image, make the image run in a container. You can start the image container, you can stop the container, you can remove a container, you can remove an image, or finally you can upload or download the Docker images from the Docker Hub. So these are few things, and there are a lot more things. And if you go in deep, then you will see lots of options available. So our workshop option is just to have a startup. Okay, now let's go to the Docker practice, how we do. For this purpose, in order to make an image, you should have, we must use the Docker build command. Okay, a Docker build command will need an application. For example, very simple application, suppose that you have a Python program, or suppose you have a HTML file that you want to convert into, that you want to run, you want to make a container holding the HTML inside the container. You should have the inside the container you should have a web server. Okay, that is the way it works. If you want to access a website, the website is basically running a web server. So we can, instead of having your own web server, you can make a web server inside a container. Okay, and the container contains the web server plus the HTML file which it will send to the client, web client. Okay, so we will see that how it works. So for this purpose, we will first make the image of a HTML page. Okay, and then we need a file. For this purpose, you need a file called Docker file. You need a special file or text file which is called Docker file. Is required to make the application image. Okay. Document, it contains aspect that you should have a Docker file. The Docker file name must be exactly like this, capital D, start with capital D. And important to know that the Linux operating system is case sensitive. The commands are case sensitive. So this one, if you say Docker with those, it will not be accepted. Say Docker file. So this is a text file you will create, and then you will type the commands. Okay, and the image. Okay, and if the Docker file is somewhere else, then you may use the -f flag to show that where is your Docker file. Okay, let me show you that what is inside a Docker file. Before I show you, suppose this is our HTML page, index.html. What I want to do, I want to simply print hello world Docker. Okay, this is a simple standard HTML. I'm pretty sure that you people are familiar with HTML, and it will display this hello world, this HTML. That is the objective of this HTML. So this is very straight, simple, very trivial, simple HTML page, which we want to be which we want to see through a web browser. Okay, and we are accessing a container running the web server. Okay, and let me show you how the Docker image look like. Sorry, Docker file. Look at this file, this slide. On the top, this is the content of the Docker file. You see, the content of the Docker file, it contains just simple 2 lines. The first line you must write in all capital, from nginx :alpine. This is the name of a web server. And from where this nginx will come? This nginx is it is just like a Apache server. Nginx is also a web server. This web server is available on the Docker Hub. Okay, so you are asking the Docker utility to bring the image from the base image, because we want to have on the base, we want to have our website, a web server. So we want to bring the web server image from the Docker Hub. So you just simply say from nginx :alpine. This is the name of the server, the web server, or the image of the web server. Then you say copy and dot. There is a dot. I don't know you guys see it. Let me make it more little bit clear. The dot refers to the HTML file, index.html file. Okay, because you are saying that, okay, copy this .html into this path, /user/share/nginx/. This is the default folder on the nginx web server. I'm sure we are familiar with the word for some of the Linux. I'm using some Linux commands or some terminology, but this is the common thing to understand, which of course we know what is meaning of folder from Windows experience. So it is a folder available on the nginx. So you want to copy this to there. That's it. This just the 2 commands are needed, and that is the command to make an image. You can see it in the red color. Docker and sudo. This $prompt is actually it is the command line interface of the Linux. You know that when we work with the Linux machine, you can work on the graphical user interface. It is also possible, like the way we use on the Windows 10 machine. You can use a graphical user interface. You can you can use the mouse to create a file or whatever. But the most good practice is that you can open a terminal. A terminal, when you open a terminal, means that it is just like a command prompt on the Windows machine. Okay, so when you make a terminal, it will print the $sign. $sign is basically when you open a terminal, the Linux operating system runs a shell program. So a shell is what? A shell is basically as interface between user and the operating system. Okay, so you are accessing the operating system to get some work done through the from the shell, which shell is actually the $sign. So on whatever you type, these commands will be interpreted by the shell, and then will be the command will send to the main kernel or the operating system. So main operating system will receive the commands from the shell, and of course we are typing as a user. We are communicating to the kernel or OS, Linux OS, through the command line interface. Okay. Now this is the now here we must use this Docker with the super user privilege. You know that on the Linux machine there is a concept of a super user. Okay, so a super user is the root user. So you don't need to go as a root. You don't need to log on as a root, but you can simply say sudo super user do. What he will do, it means that this Docker utility will require you to have a super user privilege, because in Linux we have a users and then we have a user privileges. What we mean by this, on Linux machine, we can have a common user, we can have a supervisor, or super user. They have different authorities to work. Okay, like software installation require a super user privilege. Not everybody can install, for example. So the sudo docker command cannot be executed by anyone, but you don't need to the password of the user or user as you do, because if you are doing first time, you will give the super user password. And super user password you define during the installation process. So of course, when you do the installation of the Linux, then you have to be interactive, because it will ask you lots of things, so that you should be interactive, and then you can very easily find lots of YouTube tutorials on how to install the Linux on a platform. You can, I'm pretty sure that you guys can very easily follow that instructions. So anyway, we say sudo docker, and this is the build command we use. The build command, what is our objective? We want to create the image. So when you say build, then -t. -t is basically you want to give a title. You are saying static underscore a dash web colon latest. This is the name of the image you are assigning. And the left hand side colon latest means that this is the latest image. Okay, so latest image, you can choose any image version number. You can say latest, or you can say version 1 or whatever. The last thing is the dot sign. The dot sign is basically you are saying that wherever this there are two things we need: the Docker file and our in the HTML file. The both files are wherever these files are at the same place you want to create the image. So this command will create the image, and this build command, docker build command, will take the Docker file. It will take the Docker file, and then it will use the information stored in the Docker file and create the image. So once the image is created, then you can run that image in a container. How to run a image in the container? You say sudo docker container run -d. -d means what? -d means that detach mode, meaning that when you run a Docker container, then because you are using the shell program, you are using from the shell command to run the container. In this case, what will happen? The shell will not will be keep running. It will be in a hanging state. So we don't want that. So we want the shell to come back. So that's why we will say -d, detach mode. It will start the container, it will then, and the dollar prompt will come back to us. Name is equal to web1. This is just the name of the container. Like an image has a name, still the container can have a name. You can identify the container by name. It is optional. Okay, we may not need to give this name, but it is good to give the name. And then the -p. -p is called the port number. What does it mean? You know that whenever you access a website, and every website is communicatable through a port number. What is a port number? Let me give you a very simple explanation. You know, your machine or your laptop has an IP address. On your laptop, you have several services running, or maybe the web services, for example. All these web services are identified by a port number. So there are some standard port numbers and there are some user port number. For example, 80, it is standard port number for a web server. Okay, so when we say -p equal to 8080:80, so it means you are using your user defined port number, and that is the mapping to the standard port number 80. So right hand side must be 80 for all web application. The left hand side could be 8080, 8081, 82, whatever, doesn't matter. But so we will be accessing, if you say when we want to access this one, if you want to okay, let me complete. -p 8080:80, like you are defining a user defined port number, attaching 8080 to 80, and then this is the name of the image, static dash web colon letter. This is the same name of the image which was created by the build command. Once you are done, your web server started, and it is waiting for the the HTTP request. Okay, it is purely a client server model now. Your web server is waiting for you. Okay, now you want to access this. So you know that you guys, I'm sure that we already know about this, that whenever you access a website, you don't need to specify the index.html file. Index.html file is a default web page. It's standard. For example, if you say uqu.edu.sa, you just type the website name. Then the web server of UQU will return the index.html to you, because this is the default page. So that's the same way here. If you want to access this website, if you want to see the content of index.html, so you will open a browser on your Linux machine, and then you say localhost, because you are accessing your container from the local machine. So you simply say localhost colon 8080. Now this 8080 is the same port number as I have used here. So this one, it will do what? It will return back the same content that was defined in the index.html file. Okay, if you are accessing, suppose your laptop is attached to a of course, we are all using the laptop inside our house. We have the Wi-Fi connectivity. So your mobile phone, for example, have a Wi-Fi connectivity. And if you know the IP address of your laptop, then you can specify that IP address. Okay, for example, 192.168. something. You should know that what is the IP address of your host machine or Linux host machine, of course. Then you see that the content on your mobile phone. So in this case here, we will see our content locally. Now let's go to the another example before we go to the practical session. Here, let's see. Let me make it a little bigger. Let's say now I want to run a Python application. The previous example was simply on HTML page. Now we can have a Python program. Okay, suppose you have a Python program here. That Python program, I'm not going to go into the too much detail, but simply let's understand this, what this program is doing. This program is generating a random number from 1 to 10, and it will ask the user the random number. And as long as this random number and the user guess a number, and if they are not equal, it will make a comparison. What is the guess user is making? If it is greater, then it will print this message. If it is less, it will print this message. If it is, then it will allow the user to input the second number, and if it is equal, it will go back here. If it is equal to the random number generated, it will give you a message, print guess, you win the game. So this application I can also implement. I can make this random Python program to run in the container. So for this purpose, this would be my syntax of my Docker file. As you can see here, this Docker file will bring the image of the Python program. It will make a directory called /pipp, and then this is the command it will run. You know that when we run a Python program, we say Python and then we give a Python file name. So this command will be executed by this container. So this is the second example we have learned. And the third option for us, that we can use a standard images available on the Docker Hub. For example, on the Docker Hub, you have a complete image of the Ubuntu operating system. You can bring that Ubuntu image, and then out of this image, you can simply run the shell prompt. It is also possible, and I will show you that. Okay, now this is time to go to a practical demonstration session. So for this purpose, I will stop sharing this my slide, and I will take you to a browser. Let me open the browser. Let me open this browser. Okay, and I will now go to let me share my browser. For this purpose, I will go to here and I will share my share application, and I will share the Chrome. Where is my new? Okay. Yeah, okay. This is my my prompt. Can anybody tell me that are you able to see this prompt, this page? Anybody? Please write me. Okay, you can see. Oh, very good. Okay, now let me go to this where I will go. Okay, now I will go to a site called www.katakuda.com. Okay, katakuda.com. Can everybody see that? Okay, yeah, somebody like the kittens. Okay, cool. Okay, now you see that this katakuda.com is a very nice, it's a nice learning interactive platform. Okay, and it's a training program for software engineers. Okay, and it will allow you to learn a lot of things. So I would recommend you to go to that site and do a lot of learning. Now we will go down. There are a lot of technologies available which you can learn from here. Like you can learn Docker, Kubernetes, machine learning, Linux, continuous integration, orchestration. Lots of things are here. Okay, so we are going to go into the one place. We go to the Docker section. Okay, now we will go to this section. What is the container? We will go to this site. Okay, and I will click the start scenario. Okay, now see what it has done. You see what it has done. This site has it opened a bash terminal, or it has opened a Linux terminal. Like, you don't have to have a Linux environment set up. You can use this Katakuda for your own practice. So in this, I will be using some Linux command. For example, a ls command. Ls means a list command. There is nothing. It has just opened a browser open a terminal for me. There is nothing there. Okay. Now what I'm going to do, if you note down, please, along with me, that you can I will bring someone has made a very nice practicing Docker files and Docker applications, and we will just use them. Okay, so that all these folders or Docker folders are available at the GitHub. So I'm sure you guys are familiar with GitHub. Can somebody tell me GitHub? Someone says GitHub. What is the GitHub? Have you heard the GitHub? I'm asking you. GitHub.com. Everyone, anybody? Software repository. Very good, mashallah. You know that. Okay, very cool. Of course, you guys know about that. So we will use the git clone command. Git clone command, and then I will say https://github.com/ now you should remember this name, Amin Alam. This is the Pakistani guy. He made a nice examples. I will go to Docker CNC Cloud Native Computing -Docker. Okay, just I press enter. So we got everything. If I say ls, you see the Docker folder has come. So now it is blue color. It is a folder. Okay, ls-al. It is a folder. It contains the Docker hub. Okay, Docker CNC is a folder. It is D means is a directory. Okay, it stands for a directory. So we can go to this folder. I say CNC, and in the Linux, very interesting is that if this is the unique file starting with CN, then you can press the tab key. The tab key will allow us to type the rest of the letters. Okay, so we are in this folder. If I say ls is a list command. It is same as a directory command on the Windows. Okay, in this case, in this CNC folder again has several directories. Okay, there are a lot of examples which I am not going, we will not be able to go, but I will go to a couple of examples only. Okay, because of we do not have much time for our workshop session. So let's go to this first folder 001, and then I will press tab. Okay, now I will say ls. You see that it contains 3. So you can just ignore the readme file. Don't worry about that one. But these 2 files are important. Let me try to edit this file, index.html file. Or let me show you what is inside the Docker file. If I say cat is a command, is not a name of a cat. It is a command to display, concatenate. If I say Docker file, it will just display. So you can see that we have just 2 lists, only 2 lines, as I showed you, as I have shown you before. Okay, so these 2 commands are, the first command is to bring the image, nginx image, and the second command will copy the index.html to the file system of the nginx. Okay, so let me show you. Let us just try to edit this file, index.html. Okay, I should be able to edit. If I go to this portion and I will type something for our side, from UQ Docker Docker workshop. Okay, and I say Control O to store, Control X to come out. There are a lot of editors available. There is a famous editor is called VI editor. Okay, I am using this Nano. Now I've got used to using this Nano editor. It's just like a WordStar. Some people used to use before a long time ago. So any editor, there are lots of editor available, so that's not an issue. Now here I am going to start now, because this Katabuddha is giving me user the privileged I have started this terminal as a privileged user. Okay, so I don't need to use sudo. I can directly type Docker and I say build. Let me use the build command, build, and then I will use the build, and then I will say -t. I want to give a title. For example, if I say my web 1 : latest. Okay, and then where I want to store dot. At the end I press the dot. Okay, so this dot is showing I want to do it on the current folder, whichever folder. Then I press enter. So this is the whole complete process of making the image. Now the image is there. I cannot see the image by ls command because it is not a file. It is an image. So in order for this purpose, the Docker has a special file called command called image command. I will say Docker image, and then after this image, I can use different sub commands. I want to use, if I want to process my image, if I want to remove, for example, I will use rm command. Okay, now I want to use to see the images, whatever, how many images are here, I will say ls. I think ps should also work. No ps, ls. I should say ls. You see there are 2 images. The first image is my image, web1, and then before this, the bottom image is nginx image. On nginx image, my image was created. So my image is containing all of the images, because the first image was nginx image. Okay, so you can see that it was just created 47 seconds ago. Okay, and this I don't know why it is saying 3 weeks ago. Anyway, so now I want to run it. Now my image is ready. Okay, my next step is to run the image in the container. So I will say here Docker, I will say container, and as you can see that Docker is a utility. This utility have a command called container, and then container will have further sub commands. Like if I want to remove the container command, remove the container, I must say rm, and then I must specify the container name. If I want to run it, I should say run. Okay, because I want to the run command will need the name of the image. Okay, you get it? It will need every sub command will need some parameter. So before we specify, I can specify the image name. I would say my web 1 colon latest. Okay, I can do that. But before this, I must provide some more parameters. The first parameter is that I want to give it, I want to run it with the detached mode. Okay, I must insert the my minus d, because I want to, if I start without specifying, then it will not give me a proper result. So I must specify something minus d. Then I must specify a name, and then I want to say name as my let's say the name of the container is my web 1 container. Okay, and then I must specify the port feature minus p. I should say 8080 colon 80. Okay, I'm all done. Okay, so now I'm ready to run this command. Okay, I think better let me make it more clear. Let me clear the screen, and then so that you can better see here. Now let me then do it again. Docker docker container run. Container, I should have the right spelling. Container run, and then what is required? The image name. What is my image name? I am getting old. Let me remember what was the image name. Docker image ls. Image name is my web 1. Okay, so I would use the same image name, docker, and then I would specify docker container run, and the image name my web 1. But I should insert some flags. Minus d flag, minus name flag. Name is equal to, I would try to say my web container. I want to give this name, and then minus p, and the minus p, what I want, minus p. What was this? The syntax of minus p. What is that? 1 minute. Just let me verify the proper format. Instead avoiding. Okay, that's good. Okay, minus p, and then I should minus p equal to 80 colon 80, and then I should give a space. So I'm ready. Okay, is everybody with me? Somebody has a comment? I'm sure everybody can see that. Now when I press enter, then it will give you a long container ID. Okay, now the container, it is in the running position. Now I want to see that my container is running or not. So for this purpose, I would say docker. I will say use again, because I am doing a container related operation. I must say container and ls. I think ps should also do this job. Yeah, ps or ls, both will work. So let's see ls also will work. No problem, same thing. Okay, now let's just look at here. This is the name of the image. It is giving you the complete information. Name of the image is my web 1. Command is this. 30 seconds ago it was created. It is up, status is up. Okay, and then this is the port number 8080 is mapping to 80. Okay, so I can verify my container. What is the container name? My web cont. This is the name of my container. Okay, is everybody with me? Okay, now let's, how I can see the result. As I said to you already, that my container is running a web server. Okay, that web server is accessible by the port number, the user defined port number. So for this purpose, because this is a Katakuda, it's not my own personal Linux machine. If I had my own personal Linux machine, I would open the web browser of my Linux, because Linux contains, it's a complete operating system. And one thing more important, I forgot to mention before, is that Linux is a open source. It's a free. There's no license fees. Okay, so the Ubuntu you can download free without giving your credit card information, license fee. There's not. It's a free operating system, so you can have everything, and this is a more prevalent operating system in the market. Okay, so I would highly recommend that it is good to have a Linux environment, even on the virtual machine you can install. Okay, so why I did say to you this? Yes, because this Linux is a complete system, so it comes with the web browser. I think it has the default web browser as Firefox. So if you open the Firefox in the web browser, you will say local host colon and 8080, and then you will see the result. Now, because we are using Katakuta, we want to see if we want to see the web view. Okay, so I go to this plus sign, click it, and then I choose this one. Select port to view the host one. I click it. Okay, here I must to display a HTTP server. Please enter the port number below. I will put the port number 8080, and I say click display port. Alhamdulillah. So we can see the result. Okay. So this is the first example, and let me show you the second example of my the Python program. For this purpose, I need to bring this file. Let me bring this file, and I think we should be able to also do some kind of a debugging. Let me copy this file, and then I'm sure that I might face some error. So now I'm going to show you the second example of converting Python program into the image, and then I will run it in a container. So I will say nano. Let's say I make my file app.py, and then I can paste it here. I think I should be able to paste. Yes, cool. I got my Python program. I will say Control O, store. My Python program is here. Okay, I think there should be some no. Let me just try to compile this program. Okay, I will say Python, and I will say app.py. Okay, there is some issue. Let me just try to fix this issue. I know, because I just copied it, so why it is giving me error? Yeah, I know why it is giving me error. I should say here, I should see here, I should also bring this here, I should bring it here, and then I should bring this as a tab onto the next. I'm sure you guys are familiar with Python. For those who are familiar with Python, hello, yeah, you know that how the Python program works. You know that then in Python you have a while loop here. While guess is what? Guess is the number. Of course, this workshop is not for the Python teaching. I'm just very quickly. I'm sure you guys already know about that. You must have learned Python somewhere. So now, when you have a while loop, and then this is the the body of the while loop must be after the it should be indented. Okay, now let's run this program. I'm sure it will be execute, inshallah. Let me just try that. Oh, again there is a problem, and then okay, let me see why. Let me try to fix it. It's good to do this. Why it is okay? Yeah, here we go. Okay, I think we should be able to run it now. Okay, cool. So it is running. Okay, but you see that what is this program is doing? It is asking me enter some number. Okay, it is asking me to access to type some number between 1 to 10. For example, let's say if I put 4. Okay, or let me just clear it, cancel it, and then clear the screen and then run it from the top. I would say Python app. You see that what this program is asking? It is asking me to guess a number from 1 to 10. What is my objective here? You say that this is a Python program application. I want to containerize this application. Okay. For this purpose, I need to make the image of this Python program. So before that, I want to test this program is running or not. So let's say if I guess a number, let's say 4, it is saying that it is too low. Too low. Number is too low. It means that I should enter more higher number, 6 for example. It is also high. Let's say 5. So it is the 5 was the number, you win. So my program is running very fine, no problem. Okay. Now, in order to convert this application into the image, I must have a Docker file, and I show you the Docker file. Yeah, I made it. Let me bring the Docker file. Let me copy this. I will make the Docker file for you on this Katakuda. Okay, now here I will say nano, and I think there is a Docker file here. Oh yeah, there is a Docker file. Okay, now let's do one thing. This will give me a problems because there is a Docker file already. But I should do. Let's make a directory. Make directory, for example, is I directory test. Okay, and then I will copy my file to there. I will say move app.py to that directory, to test directory. Okay, now I go to test directory. I should see this here. App.py. Now here, if I say pwd print working directory, it is in the test folder. Okay, so here I could do what? I can what I should do. Okay, now leave it here. We can just work on it. Nano, and then we say Docker file. Okay, I'm creating a new file, and I will paste this I think here, and then there is a command here, and I will press O, save it. Okay, Control X, I come out. Now my Docker file is here. I would say Docker. My Docker file is here. Okay, now I'm ready to. I have my the file is here. My application is here. App.appy, and my Docker file is here. Okay, so I'm ready to convert to make the image of this file. So I will say use the same command Docker build, and then I will say minus what I would say minus no, I just need to give a title. My title is guess full latest. Okay, and then I want to give the image what I need. Yeah, I don't need anything else. I just need says here dot. I don't see any error. Let it go. It will take some time. You see that it has okay, cool, it's working. Now my image is there. Okay, I want to see my image, Docker image ls. I should see the gas image is also here. Okay, now I want to run this image. So I would say Docker, let me make it clear. Go up. Now I will say Docker, and I will say container and container. Now here is the interesting thing. Now because this program which we have developed, it needed a user interface. You see, it requires a user interface, means that the user must interact. So I must say here -IT, interactive mode, because my program it was accepting the number from the user. So I must say -IT. Okay, and then I should use the name guess latest, and that's it. There is nothing more, or I can give a name. I can choose a name, for example, name, and then I say name as let's say name is equal to my guess. Okay, and then I can enter. Why? Oh, I have to put the. Let me show what I forgot. I got an error because I did not put the run command. So I must put the run command. Run. See, my image is running inside a container, so I can play. For example, if I choose 6, too low, and if you want 8, too low, still no, 9. It was 9. You see, so we have learned the example of making a web page to make it run in a container containing the website. And now I have an application, and then the application is running inside the container. Okay, so that we have learned. And the other last thing in this session, for example, if I want to bring the the Docker, the Ubuntu image. Okay, so I can say Docker pull, and then you say Ubuntu, and then I can say / latest. So you see that Ubuntu image, it will pull from the Docker repository. So I am bringing the image from the Docker repository. Okay. Now, if you want to see the list, you can say that it's clear, and let's say Docker image, and then I say ls. I should see the Ubuntu images also here. Okay. We have already made our images. Now we got the Ubuntu image. Now I want to run the inside this. Ubuntu is a whole operating system. In that operating system, we want to simply run the shell or shell portion. Okay, for this purpose, I would say Docker, and then I will say container run Ubuntu minus -it. Yes, -it, because I want to run the image in the interactive mode. I want to interact with the shell of the Ubuntu. I will say -it, and then I will say the name of the image Ubuntu colon latest, and in that folder I want to run the /bin/s. You see, I got this shell is running. This shell is coming from the Ubuntu image. If I say ls, there are some files in this folder. Let me make a file. For example, if I say echo, and let's say if I say hello, and then I say I copy this, I say /, and then I want to give a name, test. So I made a file. If you can see, we got a test file also here somewhere. Test is here. Okay. Now, if I want to stop this container, okay, I want to come out of it. No, I think it will not be, let me do this. I will say, now I want to stop this container. I can say Control D. Control D will bring you back out of the container. Now the container is no more running. Okay, so we have learned the three examples. We have learned that how we can make a web server to work in a container. We have learned that how we can have an application run in a container. Then we have learned that how you can bring a existing image from the Docker repository. If you go to Docker repository, docker.hub.com, hub.docker.com, you will see lots of images there. There is a MySQL images there, Redis and WordPress, lots of things are there. Okay, now let me stop sharing this, and then let me finally conclude my workshop by talking about little bit about the Docker volume and the Docker networking. So for this purpose, if anybody has any question, anybody has any question? Any question, comment? Hello? Hello? Anybody, can you hear me? Okay. Okay, so let me write down the katakuda.com, and this is the name of the site, katakuda.com. And also we what we did, you just note down this one. We use this on katakuda.com. We have said git clone. I will just writing the command which we have used, https://github hub.com, and then we have gone to cnc-docker, and then that was the command we used to bring the this folder on the our Katakuda web page. And for Katakuda, we have gone to the container section. So there are a lot of things, and also I need to tell you that if you go to this site, the site is called PDF Drive, pdfdrive.com, and then you can download, you can search a book called Docker Deep Dive. That is a very nice book. No, sorry, not deep, I wrote wrong. There is a question. Let me write down the first of the book name. Book reference. Let me write the book reference. It's called Docker Deep Dive. That deep dive book you can go download from the pdfguide.com. Okay, now there is a question Dr. Bhati is asking, where can our students use Docker? Can you tell them some real life science graduation project? Okay, you know that as Dr. Bhati has asked a very interesting question, that what is the application? Actually, when now in the North America, right now I'm in North America, I have seen that in these new trend in North America is they are going to this containerization concept. The idea is that as we have already seen that you can do that you can develop some kind of application, and then that application you can divide into smaller portion, and then you can convert a monolithic application to microservice architecture, and then you can have a you can give the senior project to the students for making a containerized based online shopping website, for example. So then you can implement the MySQL. You can use the MySQL image, and then you can use the WordPress image. There are a lot of pretty sure there are lots of example projects you can find on the internet. But my idea is that this is because it is the new trend in the market. So that's why I thought I recently have learned this Docker. So I thought to share this interesting. And when I saw in the North American market in the software trend, this is the people are going towards this side. So why not our students should learn this new technology? So that was the whole objective of this workshop. So you guys can try and then see what are how you can make your own interesting applications. Okay, now let me stop sharing this Katakuda. Okay, now let's just go to Jazakallah Khair. Now let me stop sharing and I will go back to the my slides, and I will try to conclude it within the next 10 to 15 minutes. Let me share my file. Yes, I will share it now. I'm back to my slides. There are a lot of let's go back to the after the demonstration. There are a few things left. Where is that? So let me bring that pull up. Docker practice we finished. Okay, we have, yeah, okay, here. Now as I said to you already that these Docker containers are stateless. Okay, what does it mean? Stateless meaning that they do not remember the environment. For example, you know that every website is stateless. Like if you visit a website, next time you go, they don't know who are you. They think that you are again this another person. So the same things work with the container. When the container is stopped, then the container will they will not remember. So there are two methods available. One method is called bind mounts method for the persistent data. What it will do, it will map the directory on the host machine to the directory of the directory inside a container. It's very interesting. Like you have a container, then you can map the container data. Somebody has writes on the screen. Okay. So what you can do, you have a container file system in the container that you can mount to the you have a file system in a container. You want to mount that file system to your local machine. You see, very interesting. So in this case, as you can see here in this example, let me make it a little bigger. Let me how I can make it bigger. Why it is not letting me zoom? Okay, why it is not letting me zoom? I don't know. Anyway, you can see here we have a command, run command, and then you want to mount, you will use the -v flag. -v flag will allow the left hand side is the host machine file system. Okay, host machine file system, and then it is mapped to the right hand side is the file system on the on the container. Which container? Which is which is coming from this image, nginx dot colon. Okay, that is the one method. So now let me make it okay, sorry. Okay, now this is the first method, bind method. Okay, now the second method is called the docker volume. Docker volume is what it will you can create a volume. For example, you create a volume called by the docker command, docker volume command, docker volume create by well. This is the name you gave. So when you execute this command, then the docker utility will create a folder under this under the name of myval in the /var/lib/docker/myval. This is the place the Docker will create for the volume. Okay, and then that volume can be connected to the container. Like you say, source is myval, target is this. So /vol vol is coming from this Alpine image. Okay, so this is the way that you can connect to the the docker volume. You can use the docker volume to retain the data. So whatever the information is written in the /vol in the image, that will be copied automatically to the myval. Myval you created by the docker volume command. Okay, so this is the way, and then you can copy. If you want to copy anything, then you can copy into the folder. Okay, so this is the example. I'm just giving you the ideas here, and then you can further proceed yourself. Then now let's talk about the Docker networking. Okay, let me directly go to the picture. You see that the Docker supports three kinds of network. A bridge network. A bridge network is basically it will allow all the containers connected together within a single host. Okay, suppose you have a host machine, which is the outside boundary. On this host machine, you have several containers. All the several containers can communicate with each other through the bridge. Like you can have a bridge, and this is the default bridge. In every network container will have a image. Is connectable to the bridge, and whenever a container is created, the Docker automatically assign an IP address to that container. Okay, and then I'm going to go into the commands detail here. I'm just giving you the idea. And then there are three types of the network supports. One is called bridge. Bridge is simply the communication between the all containers. Second call is host network. Host network will attach the container to the host network. Like it will connect to the network interface card of the host machine, if the network type is host. Okay. Finally, if you say none means that the container will be completely isolated. It will not be connecting to any network. So these are the three network possibilities. And also it is possible that how we can connect the multiple containers by a link command. There is an interesting command called link command. So that command will allow us to connect, to communicate the two containers. It is very important. Like for example, if you are implementing the microservice architecture into multiple containers, that container should be able to communicate. So let me give you an example here. That will be better example. Like for example, here you have a MySQL image. Okay, you can see here Docker run name. This is just the name of the ESQL, and then you must specify the environment. Like you want to give a password for the user for the MySQL, and then this is the MySQL container running by this -d combined by the first command. There are two commands. The first command initiated it instantiated or created the container running MySQL database. Okay, and then you can have another, you can start another container of WordPress image. Okay, in this case you use the link command, minus link command, and you are linking this WordPress image with what? EASQL:MySQL. This is the name of the image of the first container. Okay, so you are link the WordPress container with the MySQL container, which is of course needed. Like you have a WordPress and the image, a container, and it has a connection with the MySQL. So this is very important. Like you can have the Docker allows us to have a communication between the container. Like one microservice needs to connect to the other microservice. And then finally, Docker Compose. This is the last slide before the conclusion. Then we will go to the online quiz. Docker Compose. Docker Compose is a mechanism which will allow us to initiate the multiple containers together in one with one command. For this purpose, the Docker Compose utility requires a special file with the name Docker Compose, docker-compose.yml file. I'm not going to go into the details. You can search on internet, but I'm just giving you the idea. Like docker-compose.yml file contains all the information required for multiple containers. Like it requires it specifies the all specification for container number 1, container number 2, container number 3. So you can start several containers in one shot with one command. Okay, that is the advantage. Like in our previous example, I showed you that I started the MySQL image container with separate command. The second command was with WordPress. I can put all them together in the one file, and then I can start the all the container with the single command. So the command to start multiple container is called Docker Compose up command. That is the command you will use. And these are the 3 steps. The first step is that you create a docker-compose.yml file. You can. I'm not going to go into the content and discussion here because of the shortage of the time. But it is the idea. You can search on internet, and you can see in that book which I refer to you, Docker Deep Dive. That book you can see the Docker Compose the details. But I'm just giving you the idea at the moment. Like you can have a docker-compose YML file which contains all of the necessary information for all multiple containers you want to start together. Second thing that you must validate this file by a command called docker-compose config command. That command is to validate or verify the Docker Compose file if there is an error or not. You must run this command. And once you have done the completed step number 2, you can go to step number 3 by saying docker-compose up command. You just say up command. It will automatically look into the docker-compose YAML file, and it will launch all of the Docker images with the up command. And then you can bring all of the images together by using the docker-compose command. Okay, I think before I go to conclusion, it is good for me to take you back to show you that how you can stop a container or remove a container. So let me stop sharing this, and then I will share again my Chrome, share application Chrome. And where is this? I think this is the. Oh yeah, here. So you see here, I can. There was some question. Somebody has a question. No question. Okay. Now let me show you that. Let me show you how the Docker, how we can stop Docker container. The first example which we were doing here, that was already gone. Let me see what are the Docker. Okay, Docker images. You can stop the Docker container, but the Docker container may exist. Okay, so if I say, for example, let me show you here clear. If I say Docker container ls, you see there is only one container running, my web one. Okay, so how I can stop, remove, how I can stop this container? It is better to stop it first and then you remove it. Okay, so I would say Docker, and then I will say container, container stop, and then I should give the name of this. I think how I can give the name. Can I give the name? Oh no, it will not let me type. And then I need to give the 4.7. So how I cannot copy? I don't know why I'm not. Oh yeah, I should be able to copy. Yeah. Okay. Copy, and then I will paste it. I think no, I can should be able to paste it. Yes. Okay. So it will stop. The container is stopped. If I want to see it again, it says there is nothing. It's gone. Okay. Now, but the container is still there. It is stopped, but it is still there. How I know that it is still there? I can say here Docker ls, and then I will say -a. You see, the my web one is there. This container still exists. The exit status is exited. It was exited, but still the container binary or the container is there. It's the file system, like container is still, but it is in the stop state. You can start it again by using the start command. Okay, you can do that. So, but in this case, what I will do, I can if I yes, there is one thing important. If I use the start command, then it will make another container, a second container in addition to the previous container. But if I want to run it again, I can just simply say exec. Exec command will allow me to start the container. Let me try that. Docker, I would say Docker, and then I say exec, and then I should say exec, and I think I should say minus same idea. I should say let me just try that. My web one. No. Exact, and then I say minus. Okay, I think I should leave this example. So let me just show you how you can remove a, a container. I would say Docker rm, and then I should remove this. I can the name, the ID of this container, copy, and then I will say paste, and then it will remove. Okay, it is removed. Okay, these are the commands. And also finally, let me show you that how I can remove an image. So I would say, let me make it clear. I would say Docker image ls. Like there are different images available. So image IDs I will have to use to remove an image. For example, let me remove the image of the my web one. So I can say Docker image rm, and then I will give them this ID. I can copy this, I can paste it here. So image is gone. Okay, so this is the way we can remove the, we can stop, in order to remove a container, you must stop the container, then you remove the container, and then you remove the image. So this is the way you can get rid of everything. Okay, now I think let me just go to the conclusion section of my talk. Share file. I will go to my conclusion, and then we will complete this session, and then we will go to the our quiz. Okay, in the meanwhile, have you guys have downloaded kahoot.it? Some of you? Okay, well, we'll do that in a minute. Okay, now conclusion. What we have learned in this workshop, we have seen the issues of monolithic and architecture, and then we have seen the issues related to the software incompatibility, and we have seen that how the Docker practice can help us for this also for the issues related to monolithic architecture, and then we have seen what is the cloud native architecture? It is the new trend which joined four things. They joined CI/CD, continuous integration, continuous development, DevOps, microservice, and container. And also we have seen the whole life cycle of the Docker practice, like how to create a Docker image, how to run a Docker image in a container, and then how to stop a container, how to remove a container. And also we have learned that how to remove an image. And also we have seen that how you convert how you can make a web application into a container, and how we can run a application, a Python application into a how we can convert an application into image, and then how we can make image to run in a container. And finally, we have seen the Docker volumes importance and the Docker networking. And and then we have seen how we can start the. Okay, Dr. Bhatt is asking the pin. So let me go to the. Let me start my this one, and now we are going to go to the our practice, the practice quiz. I will stop this one. I will need to share my Chrome, my application. I will go to Chrome, and then here. Why it is not letting me share? Okay, I think I should stop this one, and I will stop this one. I am here. I will say why it is no Chrome tab. Okay, yeah, I think there is no Chrome tab. Not me. Let me open Chrome tab. I will say share application Chrome. Chrome new tab. Okay. Now again this nice cat. Now I will go to my Kahoot login for teachers. Kahoot login for teachers. Okay, login. I need to log in. Okay, I will log in. Sure. I don't remember. Did I use my Yahoo or Gmail? I don't know. Let me just verify. No, maybe not. May have used Yahoo. My Dr. Sayed Misbahuddin yahoo.com, and then I will give my password. Oh, why? What is the problem? Did I try something? Okay, just give me a minute. Why it is not letting me log on? My God, why? What happened to me? Okay, let me just try this. Reset my password. Sorry. Okay. Maybe not. Why it is this? Okay. Okay, let me 1 minute. Let me just unshare my screen because I'm just using. Let me come back to. In the meanwhile, you can just uh, just let me just give me a minute. Okay, I will be back. I will go to my reset my password. Okay, Kahoot password reset. Reset my password. Okay. Okay. So what is he asking this? Okay, hello, everyone here with me. Okay, now let me just share the Chrome and Kahoot. Where is that Kahoot? Kahoot, this one maybe. Okay. Uh, okay. Yeah, I think you can see that. Hello, everybody can see that. Okay, cool. So now I will start this. Start the quiz. Uh, why it is not running? Uh, I have to. Okay. Can you start? Can you accept this? Anyone have Kahoot.it? Did you? I think. Let me start. Let me. Waiting for user. It says the waiting for user. Uh, Waiting for user. Oh yeah, I think I can. Oh no. Okay. Okay. Oh no, this is wrong. Sorry. This is wrong quiz. I will stop sharing. This is a not right quiz. Let me just go to the proper quiz. I'm sorry for this. Let me go to my quiz. I will stop sharing and then I will see which quiz I had. So I will say stop this one, leave this one. I will go back to my Kahoot login again. Why I don't know where is that. Sorry, give me a few minutes for Talker Sayed Misbah at gmail.com and I have I say okay. Okay. What is this? Okay, I'm sorry. Actually, it looks that there was some issue. I don't know. I had made a quiz, but unfortunately, I could not find it. Maybe there was something wrong when I created the quiz. I have. Anyway, so let's just conclude the session, and then if you have any question, you can ask me here, and then otherwise we will conclude it. Anybody has any question? Oh, yeah, Dr. Bhati says that okay, everybody passed. Yes, everybody got 100%. Unfortunately, I am sorry. I was wishing to play this. It was a, yeah, it is a coronavirus semester. Yeah. Yeah, that's right. So there is no thing. Okay, okay. I will. I think I have shared this slide with Dr. Ahad, and she should be able to share it with you people. I appreciate your attendance, and I hope you may have enjoyed this session. And then please explore the avenue of this new trend of the DevOps and cloud native computing, and I'm sure you will find a lot of interesting examples and applications on the web. And this was just a startup. And then if you have any question, you can share with my with my personal email address. Let me write down here. My email address is Dr. Sayyed Misbah at gmail.com. So if you have any questions, okay. So I just leave the session. Thank you very much. So I will try to make